Hello friends, did you know that Elon Musk has just confirmed that the Neuralink is officially entering its scale era? By 2026, the company aims to move from exclusive clinical trials to high volume production of its N1 brain computer interface BCI chip. But the hardware is only half the story. Neuralink is also preparing to roll out a fully automated surgical procedures using their next generation robots. Let us explore this further. Welcome back to the channel. Future thinkers, we have been talking about Neuralink for years, watching Elon Musk's ambitious vision unfold from the initial demos with the pigs and monkeys to the very first human trials. It has been a journey, but today we are not just talking about the future anymore. We are talking about a concrete timeline for a massive, unprecedented shift. Elon Musk just confirmed it. Neuralink is no longer just a research project. It's officially declared entering its scaling era. By 2026, the company aims to move from exclusive clinical trials to high volume production of its N1 brain computer interface chip. Think about that for a second. We are talking about transitioning from a handful of experimental implants to potentially thousands, even millions of devices being produced. This isn't just an upgrade, it's a quantum leap for neurotechnology. So, what does high volume production actually means in the context of brain implants? For years, the bottleneck has been the intricate manufacturing process and the highly specialized time-consuming surgical procedures. Neuralink's existing facility at Fremont, California, has been focused on refining these processes. But the goal for 2026 is to build on a manufacturing capacity that can churn out N1 chips at an industrial scale. This isn't just about making more chips, it's about making them efficiently, reliably, and eventually affordably. Elon Musk has been, speaking about reducing the cost of these implants, ultimately aiming for something comparable to a LASIK eye surgery. This mass production push is the first critical step towards achieving, that kind of accessibility. Imagine a world where a brain implant isn't a miraculous one-off event, but a standardized medical procedure. That's the vision of Neuralink, and that is what it is chasing. But the hardware, which is the N1 chip itself, is only half of the monumental story. The other equally crucial development is the advancement of Neuralink's surgical robot. For mass production to truly happen, the implementation process needs to be radically streamlined. And Neuralink solution, which is a fully automated surgical procedure. Elon has teased the idea of a 600-second outpatient procedure. That's about 10 minutes to implant a device directly into your brain. How is this even possible? The key lies in the robot's precision and a clever design change. A new, thinner thread that reportedly bypassed the dura mater. The dura is the tough membrane surrounding the brain. Traditionally, breaching it carries higher risk. By designing threads that can go through it more minimally and within prescribed confinement, the robot performing the precise insertion that aims to drastically reduce surgical complexities and recover time. This shift is critical. It makes the procedure less invasive, safer, and faster. All essential ingredients for scaling to a mass market. So once these implants are being produced at scale and the surgery is fast and automated, what will then actually do for people? This is where the true impact of Neuralink 2026 roadmap comes into focus. While the initial trials have primarily focused on restoring motor function in individuals with paralysis, giving them control over computers and prosthetics, the ambition is far, far greater. We are expecting to see an expansion into new medical applications. Think beyond just restoring mobility in spinal cord injuries. Neuralink is actively exploring trials for conditions like blindness, aiming to restore sight through direct neural stimulation. They are also working on speech restoration, allowing individuals with conditions like ALS to communicate seamlessly through thought to text interface. This isn't just about fixing a broken body part, it's about re-establishing fundamental human capabilities. The potential here is nothing short of revolutionary for millions worldwide. Now, $64,000 question, or perhaps $1,000 question, is whether this mass production eventually lead to a consumer grade brain chip for enhancement rather than just medical necessity. Elon Musk has always spoken about Neuralink's ultimate goal being human AI symbiosis, augmenting our natural intelligence to keep pace with the advanced AI. While the immediate focus for 2026 is clearly medical, the move to high volume production is a prerequisite for any future consumer aspirations. Think of it like this. The first computers were massive, expensive machines for specialized purpose, and then over time they became smaller, cheaper, and affordable. Neuralink seems to be following a similar trajectory. If they can get the cost of the chip and procedure down to say $1,000 to $5,000, then the conversation shift dramatically. Is a future where the brain upgrades are as common as smartphones upgrade truly on the horizon? The push for scaling and bringing that speculative future significantly closer. Of course, with any technology, this transformative, especially one that interface directly with the human brain, safety and ethical considerations are paramount. Neuralink has faced significant scrutiny, particularly regarding animal testing and early trial procedures. However, their move to human trials and now to mass production indicates that they are making strides in satisfying regulatory bodies like FDA. Recent reports suggest continuous engagement with FDA focusing on long-term biocompatibility of the implant and the safety of the surgical robots. As they scale, public trust will be critical. Transparency, rigorous testing, and clear communication about risk and benefits will be more important than ever. We are entering uncharted territory, and the ethical framework of such widespread human AI integration are still being developed. It's a conversation we all need to be part of. So to recap, Neuralink announcement for 2026 is a game changer. High volume production of the N1 chip paired with fully automated 10-minute surgical procedure is set to radically accelerate the availability of the brain-computer interface. This means a massive expansion in medical applications, potentially restoring crucial functions for millions and setting the stage for a future where human augmentation moves from science fiction to science fact. This is a story that will redefine our understanding of the human potential. The age of mass produced brain computer interface is truly about to begin. What do you think about Neuralink's aggressive 2026 roadmap? Would you ever consider a brain computer interface if it becomes as common as safe as LASIK eye surgery? Let me know in the comments below, and don't forget to like this video, subscribe for more future tech insight, and hit that notification bell so you don't miss out our next deep dive. Thank you for watching, and I will see you again in the next one.